Alright, in this section we're going to start 3.3, which is in pre-cal, which is the root form of quadratic equations. And we're going to look at how that different kind of equation. If you remember, we did vertex form or standard form last time, excuse me. We've got to cover root form, and the next thing that we'll cover will be vertex form of quadratic equations. Now, in this type of form, we can read the roots or the zeros, or also, if you remember, the other thing you hear this called is solutions, where it crosses the x-axis. You can read that right from this equation. And the general equation you need to remember is this one right here. And these root 1 and root 2 are the zeros for the quadratic. So given this, you need to remember still, if there's a negative in front, that means it opens downward, so the direction here is down. The axis of symmetry, okay, we can get the axis of symmetry because it's going to be halfway between the roots, or where it crosses the x-axis. So in this case, one of these roots, x, remember you kind of change the sign, it's the value of x that makes that factor 0. So one of our roots is -6, and the other one is +4. Okay, so we can find the distance halfway between. The midway would be -6 plus 4 over 2, which then would be -2 over 2, or -1. So x equals -1 is our axis of symmetry. On the vertex, if you remember, that tells us the x value of the vertex, so we can plug that into the root form and figure out what the y would be at -1. Okay, so we have -2 times -1 minus 4 times -1 plus 6, and that's going to be -2 times -5 times +5. So that's -25 times -2, which is +50. So our vertex is way up at 50, -150 is our vertex. Okay, we have at -6 and at +4 zeros, and we can kind of sketch our graph from there, our quadratic, which with this pen looks more like a V than a U, but okay. The y-intercept, remember what you do with the y-intercept is you make your x equal 0. So for the y-intercept, that's where x is 0, it's where it crosses the y-axis. So we need to find f of 0. So that's going to be -2 times 0 minus 4 times 0 plus 6, or -2 times -4 times +6, or +8 times 6, which is 48. So the y-intercept is at 0, 48. Okay, this equals 48. The roots, again, we can read right from the equation. They are x equals 4 and -6, so our roots are at 4, 0, and at -6, 0. The domain of every quadratic is all real. In the range, this has a maximum, so it goes from -infinity up to 50. It includes 50, so you have the square bracket and a curved bracket at negative infinity. Okay? Now I'm going to move down to the next example, so this will go away when I click the mouse, and we'll move down a bit. See if we can get it without changing pages, where we can see all of it. Yep. Okay, there we go. Now looking at this example, f of x is equal to 1/2 x plus 4 times x minus 2. Well, again, this means we have x's, where it crosses the x-axis is at -4 and at -2. So if you want to fill those in first, we have -4, 0 and -2, 0 for our roots. Okay. This is a positive 1/2, so it opens up. The axis of symmetry, again, is halfway between these two roots. Well, it's easy to see where that is, but let's mathematically do it. We have -4 plus -2 divided by 2, which is -6 divided by 2, or -3. So our axis of symmetry is that x equals -3. Remember, that's a vertical line right here at -3. So you have to remember that that's an x equals line, and the equation for this axis needs to be a linear equation. It needs to be x equals. Don't just put -3. Okay, the vertex is the x value of the vertex is on the axis of symmetry, so that's at -3. Now we have to figure out the y, so we figure out f of -3, and that's going to be 1/2 times -3 plus 4 times -3 plus 2. We just put -3 in for the x's. That's 1/2 times 1 times -1. And 1 times -1 is -1 times 1/2 then is -1/2. So if we go down here, we're at 1/2 right there. Okay. And then we can kind of sketch in our quadratic. Leaning a little far there to the right, but the y-intercept is where x equals 0, so f of 0 is what we need to do to find our y-intercept, which is 1/2 0 plus 4 times 0 plus 2, 1/2 times 4 times 2. 1/2 times 2 is 1, so that's just going to be, the y-intercept is at 0, 4. Okay. The domain is all real numbers, and the range, the lower part of the range, is at -1/2. Again, you're looking at the y values, and it goes all the way to positive infinity. It will equal 1/2, but it will have the curved bracket at infinity. All right, we have a few more examples, so let's look at those. Let's go on to the next page. Again, when I hit the mouse, it's going to disappear. We're going to move on to the next page. Okay, we should be able to see examples 3 and 4 and a bit of 5. Maybe enough to write. Let's go up just a tad. Right there. Okay. So write the equation. Now we're given some information, and we're expected to write the equation. It has roots of -2 and 3, so this would be r1. This is r2, and the y-intercept is -12. Okay, so if you want to write that over here, you can do that. Root 1 is -2. Root 2 is 3. So let's just put the roots into the general form. We have y is equal to a. Now, remember, you change your sign when you put it in, because that's the value. We have x plus, well, let's just write the form. X minus r1 times x minus r2. So when we put that in, y is equal to a times x minus a -2, which is going to be plus 2, and x minus 3. Okay. Now the y-intercept tells me that I have a point on this graph that is 0, negative 12. And I can substitute that in for the x's and y's and figure out what a is. So our equation, our final answer, is going to look like this, but we're going to have a number here for the a that we don't know yet. We're about to figure that out. Okay, so that's going to be our answer, but we're going to figure out what goes here for a by using this point. So we put negative 12 in for y. A is still a variable that we don't know. 0 goes in for x. Okay, so now we have negative 12 is equal to a times 2 times negative 3. Negative 12 is equal to negative 6a. So a is equal to 12 over negative 6, or positive 2. And so that positive 2 goes right here where a would go, and then that's our equation that meets the criteria given in example 3. So if you're given the roots, you can use this root form to help you discover the equation. Now let's look at example 4. The equation of a quadratic function with x-intercepts of 4 and negative 4 and a y-intercept of negative 6. So we're going to do the same thing. Root 1 is 4, root 2 is negative 4, and the y-intercept is at 0, 6. Okay. So here we go. We have y is equal to a times x minus 4 times x minus a negative 4, so that'll be x plus 4. Now we're going to substitute this in for our x and our y. So we have 6 equals a times 0 minus 4 times 0 plus 4. And 6 is equal to a times negative 16. So when I divide 6 by 16, I have a is equal to negative 6 over 16. And I reduce that fraction. I can divide each by 2, and that will be negative 3/8. So now we're going to write this as a function. You can write it y equals, or you can write f of x. That's how you would write it if you wanted function notation. Equals negative 3/8, because that's our a. And then you write the roots, x minus 4 times x plus 4. Okay, and that's the formula of that quadratic. All right. Now I'm going to move 5 up a little bit so it's a little more visible on the page. So I will hit the mouse and move it up. Get back our pen. Now we want a quadratic with the zeros of negative 3 and 2 and a y-intercept of negative 1. So root 1 is negative 3, root 2 is 2, and the y-intercept is 0, negative 1. So y is equal to a times x plus 3, because again x minus a negative 3 is going to give me x plus 3, times x minus 2. Now I put my x and y. This is the x and y I'm going to use to help me discover what a is. So negative 1 is equal to a times 0 plus 3 times 0 minus 2. Negative 1 is equal to a times 3 times negative 2, or negative 6a. So I'm going to write it with a on the left. Negative 6a is equal to negative 1. Divide by negative 6. So negative divided by negative is positive. A is equal to positive 1/6. All right. So when I rewrite my formula, f of x in root form is equal to 1/6, positive 1/6, x plus 3 times x minus 2. Okay. And that is our notes over using root form of a quadratic function.